Good evening, everyone. Welcome back to day 4 of our event. We are happy to see you, many familiar faces joining us today for another day of exciting presentation and discussions. Once again, I welcome you all to the fourth session of our 5 days faculty development program on digital image processing using Matlab, organized by Institute for Engineering Research and Publication IFERP in association with our academic partner, PES Institute of Technology and Management, Shivamoga. Now, coming to the session, before inviting our speaker of the session, Dr. J. Somasekhar, to take the spotlight, I would like to give an introduction about him and his expertise. Dr. Somasekhar, as a resource person speaker, he has delivered 145 technical talks of AICTE FDPs, ISTE FDPs, STTPs, UGC, FDPs, webinars in 12 states of country. He got all Indian rank of 43 the GATE exam with a 98.4 percentage. He has 16 years of experience in teaching and 6 years of experience in research. He has published 23 research articles in leading journals, indexed in SCI and Scopus, conference proceedings, and 2 international textbook chapters. Thank you all once again for joining us today. I hope you all have an enjoyable and productive day. Now, Dr. J. Somasekhar will be sharing his insight on digital image processing using Matlab. With his expertise, knowledge, and experience, we have no doubt that this presentation will be informative, engaging, and thought-provoking. So, without further delay, ado, please join me in welcoming Dr. J. Somasekhar to take the session chair. Over to you, sir. You can start your presentation, sir.
Can you hear me, madam? Is it audible, madam? Hello, is it audible, madam? Madam, is it audible, madam?
Yes, sir, audible.
So hope my screen is visible to all the participants, madam. Madam, whether my screen is visible, madam?
Yes, sir, it is visible.
Okay, thank you, sir. So, good afternoon, all the participants. So, welcome to the fourth day session of 5 days FDP on digital image processing using Matlab. So far, we have completed 3 days. So, first day we have completed introduction of image processing, application techniques, and the introduction of Matlab. And second day, we have covered some of the hands-on Matlab basic functions and image enhancement techniques with hands-on. And third day, also we have covered some of the image enhancement techniques for noise reduction with the hands-on for grayscale images and color images we have covered in yesterday's session. So today we'll go for one more enhancement technique that is called contrast enhancement, and with complete mathematical intuitions, algorithms. After that, hands-on session we'll try to complete. After that, segmentation, edge detection. So that concept is left that we'll try to complete tomorrow's session. So now once again, welcome to day 4 session of FDP. So before started session, just now I have received query from Nirmala madam. Just now when I have verified my mails, I received this mail. So the error is error in subplot line 6 like that. So what is the main problem is here, madam, what we have done mistake. So the participant details here I have highlighted. So you can observe that the name of the function and name of the program names are same. So what is the function we have applied here? Subplot with 3 parameters that we discussed: row, column, and image location. So what we have specified here, 1 to 1. So you are considering 1 row, 2 columns, and image location is 1. So but here the main problem is name of the function is subplot, and the program name also you have considered subplot.m. So it should not be same name. So it should be some other different name. Suppose if you make it as a name of the program is inbreed, then you will get error. So because of that reason only you are getting error in subplot. So after this session, just you can make it as subplot one, some other name. You try to make it as a program name with extension .m. Obviously, because of MATLAB program, you won't get this error, madam. So you check it, madam. After the session, you can go through once again. Just you try to change the program name. So that is sufficient, and you will get here. I mean, you will get output what we have discussed. These things we discussed in the first session only. So then, if we have time, we can go through that recorded session also. You can find complete insights of the subplot and various forms also. So hope the doubt is clarified. And of course, we have received few more mails that also I will reply because a little bit busy with exams works. Otherwise, I can reply immediately. So this I found just now. That's why immediately I have taken into consideration. But other emails, what I have received from the participants, I'll give reply. All are simple queries only, not that much complicated. And all the mails I will reply within short time. So hope that doubt is clarified. Yeah, thank you, madam. Yeah, fine. So whenever you are asking any query, try to attach screenshot like this. So even Nirmala madam also attached a screenshot like this. That's why I'm able to copy paste that screenshot. I'm able to show to all the participants, so that the other participants also won't repeat this mistake. Because name of the function, even if you take C program, leave it MATLAB. Even if you take C program also, suppose if you take F printf, F scanf, let us assume if we take printf scanf. So if you use it as a name of the program, you'll get error. So the functions, the library name should not be name of the programs, even C, C++, or MATLAB, or if it is Scilab, etc. programs. This is a very simple thing. So fine. So just to clarify that doubt, I'm showing to all the participants. Maybe you may face this type of similar kind of problem in future. That's why I'm explaining to other participants also. Okay, man. Thank you, madam. So now we'll move to the today's main concept. So we have completed image enhancement. So once again, I want to give clarity. Whenever if I take enhancement, it may be noise reduction, or it may be a contrast enhancement, or it may be deblurring, etc. So I'm not giving all the techniques because we have n number of techniques if we take image smoothing. But what I have explained median filter, what is the mathematical intuition, what is the MATLAB code, and how to apply color images. With various cases we have discussed in detailed. So not simply I'm taking one example with MATLAB code. I explained how to apply to the given images also. With numeric examples, I have explained max filter, min filter. If you find any other filters also, try to apply similar logic, because within these five days sessions, maybe every day 1.5 hour maximum, it is not possible to complete all the noise reduction functions, maybe all the concepts of image processing. So just I am showing the path that we can consider as a motivation towards to study other concepts. So that's why just I will give the brief idea for one concept that we can consider as a main agenda. Based on that, we can go for the topic. That's why at the end of each day, I'm giving some of the resources to learn better about MATLAB and image processing also. So that's the main clarity I want to give before completing. I mean, before going to the next image enhancement technique, that is called image contrast enhancement. So now, so when you take here some of the images, so we can find very low contrast. So because of that reason, we are not able to see the objects properly. This is very important issue when you are applying deep learning, when you are applying machine learning, or when you are applying image analysis or image processing techniques. So always most of the images having low contrast. That's why we have n number of articles on contrast enhancement techniques for the low contrast images. It may be medical images, satellite images, maybe natural images, maybe etc. other application type of images. We can check it in Google. Even IEEE transactions only, you can find n number of that much research is going on this. Of course, each method having pros and cons. That is obviously because of that reason only research we have keep on continuing, and there is no end for research also. So in this case, these are the images suffering with the poor contrast, low contrast. Because of that reason, we have to go for better contrast. Based on that, we can go for further image analysis. Image analysis maybe segmentation, or it may be classification, or it may be object recognition or detection, etc. Even if we take original image, after enhancement, we are able to see object better than input image. That's why we can go for further step. So here the main aim of image enhancement is to improve the visual appearance of the image that I have already shown in the previous slide. Input image, output image. Based on that, we can see better visualization or better contrast in the output image. So most of the images I already shown some of the images like medical images, satellite images, natural images, aerial images, even other type of images suffer from poor contrast. Because of that reason, we are not able to go for object detection or object enumeration or maybe object classification, or it may be segmentation, etc. So because of this reason, we have to go for some enhancement techniques. Based on that, we can go for better enhancement and we can go for image analysis. It may be a segmentation or classification, etc. So our main aim is we have to improve the quality, or we have to improve the contrast. Quality means maybe noise reduction also quality only, but here we are focusing quality in terms of contrast enhancement. That is our objective of the image enhancement, under which we are looking for contrast enhancement of the input image for further image analysis or maybe further processing. So we have an input image. Let us assume this is the input image f of xy. Maybe because we know image is nothing but two-dimensional function xy or spatial coordinate system, and output image is, let us assume, z of xy. So some enhancement technique understood, that some contrast enhancement technique we have to apply t, so that output image g of xy equal to t f of xy. That means t, the transformation or the algorithm t is applied to the input image f of xy. That's why we are getting better quality image. So this is a basic idea behind this, and we are talking about spatial domain only. So frequency domain is out of the scope of our session. So if we take, this is an input image, and some of the objects we are not able to see properly. So after contrast enhancement, we are able to see better than input image. So for that, we have to go for contrast image. Based on that, we can see better quality of the image, and that using that we can go for object recognition or object counting or enumeration that we can do. So here, before going to that, we are going to use, we have so many contrast enhancement techniques. We are focusing on histogram processing techniques. That is very simple techniques. So that is the basic idea. These are the simple techniques. By using that, we can try to increase the contrast. Maybe based on that, we can go for other contrast enhancement techniques also. Each contrast enhancement techniques having pros and cons. So based on that, we can go for any new novelty of the contrast enhancement methods also. Then we can go for publications. So actually, what exactly histogram show tells? So it shows the frequency of pixel intensity values. So for example, 10 pixels frequency. Let us assume the image pixel 10 having number of pixels 15. That means the frequency of the pixel 10 is 15. Let us assume, so intensity value 15, the number of pixels having 15 is 7, then the frequency is 7. So then this, we have to go for graphical representation, because if I take a image 500 cross 500 or maybe 200 cross 200, it is difficult to count how many pixels having intensity value 10 or how many pixels having intensity values 15. So when you go for histogram, we are able to see clearly the frequency of each pixel value. So pixel 200, what is the frequency? That means how many number of times repeated. The intensity value 255, how many number of times repeated. So if you want to see the full clarity of the frequency distribution of the pixels, we have to go for histogram. So for example, if you want a clarity for real-time example, let us assume, so 5 students got a distinction, let us assume, and I can call it as a distinction, and 7 students got first class, and 10 students got second class. So or maybe 8 students got 8 students failed. So this is the data I have. I want to go for histogram. So for that, it is a histogram is a two-dimensional function, x and y. So x indicates, let us assume, the grade or maybe class, so grade, and y indicates the count, or we can call it as a frequency. So that is the basic distribution of the grade as well as frequency. Now we have to go for graphical representation for this. So let us assume distinction. So that is the grade and 5. So we have to make it as a, just like it's a bar chart. So 5 and first class 7, and second class make it as here somewhere 10, and failed students 8. So this is 5, this is 7, this is 10, this is 8 somewhere, let us assume. So this is the histogram of the number of students got distinction first class, second class failed students. Easily by looking this graph, anyone can understand, oh, distinction 5 students or 7 students first class, like that. So in similar way, whenever we have a image data, we have to show graphical representation so that we can identify the frequency of each pixel value. So for that, we have to go for histogram of an image. So now we can see, so this is the image. So some image we have a matrix form, and this is the histogram. So for example, if we take, let us assume one only once. So intensity value 1, the frequency is 1. Suppose if we take 2, so 2 is not there. 3, 1, 2, 3, 4, 5, 6. So the intensity value of the pixel value is 3 is 6. Similarly, 4. What is the intensity value? Let us assume 5. Next, in pixel value 5. Let us assume intensity value, frequency is 3, like that. So by looking at this diagram, we can identify easily. So what is the distribution of the pixels in the entire image? So actually low intensity value like 5, 1 having more number of pixels distributed. So because of that reason, we can identify the image having low contrast. So for example, if you take, let us assume, so we have a histogram like this. So this is the histogram I am assuming. So let us assume this is the histogram. Maybe here some pixel intensity value. So which indicates that most of the intensity values comes under low pixels having low intensity values. So that means here clustered, all the intensity values are clustered here. So that means all the intensity values having high frequency. But when you come to the high intensity values, low frequency, here you can see 250, 255, or maybe 180, etc. These intensity values having very low frequency, but low intensity values having high frequency, which indicates that the contrast is low. So whenever if I take 10 low contrast, if we take, let us assume 160, so good contrast. So that is the meaning. Low intensity values indicates the little bit darkness, high intensity values indicates the brightness. So that is a basic idea that we discussed in the first session. So when you take one white color, 0 means black color. Similarly, if you take 0 to 255, so it will start from low brightness low to so high brightness. So 0, 1 to 10, like that. If you take it, you will get low contrast. Because of that reason, we have to increase these intensity values. Based on that, we can find better contrast in the input image. So that is the brief introduction about histogram. So by using that only, we are going to apply various histogram equalization, histogram processing techniques for better contrast enhancement. Now, what is the Matlab function to display histogram? Anyhow, I will show hands-on also. So we can go for a simple Matlab function that is called imhist. By using imhist, it will calculate histogram of an image. So just we have to use imhist. We have only one parameter here, image. So just we can give a grayscale image as B, then you can it will display histogram of image. For example, if you take same example, here you can see the histogram here. So most of the values are the highest frequency values are 100, 120, like that. These values having very highest frequency. So more than 550 intensity pixel values count here. And of course, the overall, if we take this histogram, the intensity values or the color values are almost equally distributed. Of course, the brightness is not that much low. Here we can find better contrast. So that's why there is no issue. But when you go for further slides, you are able to see most of the histograms having high intensity values or high frequency with low intensity values here only. So most of the intensity values having high frequency and clustered here instead of high intensity values. So in that case, we can find low contrast of the input images. For that, we have to go for so better contrast enhancement, so that we can able to see the better quality of the input image, that we can go for further processing. So here basically the basic idea of this program is, so how to find or how to display the histogram of an image, just we have to use imhist function. So by using imhist function, so we can display histogram of an image. Suppose if we have color image, we have to go for histogram for each channel like RGB. Of course, we can go for program with RGB histogram one stretch also if we are looking for any research. Anyhow, that research directions I will show. I have some publications published in that area that I will show later. Maybe tomorrow's session at end, I will show the research directions also. Here also you are able to see, so just imhist function and histogram of an. Of course, we can put title also. So imhist, don't put imshow be like that. So you won't get proper histogram. Always whenever if you want to display figure imhist, instead of imshow, we can go for imhist and the grayscale image, that is B, and title if you want to keep, we can put. Of course, we can go for x-axis, y-axis also we can put by using plot command. So here when you see this histogram, so when you come to this histogram, so this is a low contrast image, and most of the pixel values having a low pixel values having high frequency up to 150. Whatever pixel values here we are able to see, all are having high frequencies, 300, 3000, sorry, 3000, 3500. That many number of pixels having 120, 150, 140 intensity values. So that's why, because of that reason only, so we are able to see low contrast of the input image. When you apply some of the image enhancement techniques, contrast enhancement, understood image enhancement, here contrast enhancement, what we are discussing. So we are able to see the equal distribution of the intensity values. Because of that reason, we are able to see the better contrast. So this is the output image, and by using any one of the histogram processing technique, and we are able to see the better contrast. So now how to see this output, that we will discuss with the MATLAB code and mathematical model or maybe intuition also. So up to here we discussed, so what is contrast, why we have to go for contrast enhancement with examples, and what is histogram, and how to go for MATLAB code for histogram. That means if you want to display histogram by using MATLAB, we have to go for imhist function. By using these basics, we'll go for one of the contrast enhancement technique. By using that, how we are going to increase the contrast. So first we will see the algorithm. After that, we'll go for MATLAB program execution hands-on also. So up to this, we have discussed only basics only. Now we will go for contrast enhancement technique, that is called histogram equalization. By using histogram equalization, that's why I given histogram definition also. So by using histogram equalization, how we are going to increase the contrast of an input image. So here we have algorithm. It's very simple algorithm. So we have a grayscale values and a number of pixels that we know how to calculate. So this whatever steps are given, I'll explain through example. Based on that, we can understand. So basic simple idea is, so we have to calculate probability PDF. After that, we have to calculate cumulative probability. After that, we have to calculate number of gray levels -1 into cumulative probability, and we have to make round figure. This is the transformation. After that, we have to make round figure. Then finally, the transformation of input image to output image. So this all the steps I will explain through example. Based on that, we can understand better. So same thing, sometimes we have, instead of giving image, maybe sometimes you'll get RK, NK. RK indicates gray level values, NK indicates intensity values. That means number of times repeated, that means frequency. So RK, let us assume 0, gray level value 0, NK is nothing but frequency is 15. That means the intensity value 0 having 15 times in the input image. Suppose if RK value is 10, NK value is 150, that means the gray value 10 is repeated 150 times in the input image. That is the meaning of RK, NK. RK means gray level value, NK means frequency or count. And we have to calculate probability for each gray level, that is called P of RK. We know what is the probability definition: favorable number of cases by exhaustive number of cases. Then we have to go for cumulative probability. What is the meaning of cumulative probability? Just we have to add with the previous probability, which leads to the cumulative probability. Then multiply L minus 1. L is anyhow given in the problem, number of gray levels -1 into cumulative probability, and we can go for round off. That is the final step of the histogram equalization for contrast enhancement. So through example, we'll discuss so that we can understand how we have to apply histogram equalization for contrast enhancement of the given input image. So this is a simple example I'm taking. I'm taking a digital image of size 5x6 and how we are going to perform histogram equalization for contrast enhancement. And by using that, we will see Matlab code also. To understand what is exactly happening through algorithm, and MATLAB function is very simple. Just we can use hist eq. So by using that, we can directly make a histogram equalization. But what is exactly happening beyond that means we should know the algorithm. Otherwise, simply we can apply, you will get output. There is no use. So that's why almost all the concepts, whatever we have discussed, first I'm explaining the concept with numeric example. Then I'm applying the MATLAB code. Just applying MATLAB code means within 2 hours we can complete all those things, whatever concepts we discussed so far. So here we have an input image. Here RK values, RK means gray level values, we have to note down. So 0, 1, 2, 3, so on, 7. Minimum is 0, maximum is 7. That is the gray level values. In this input image, as you can see here, number of gray level values are 8. So 0 to 7. And NK is nothing but number of times each gray level is repeated. If you take 0, how many times repeated? 1, 2, 3. 3 times repeated. That means NK equal to 3. And gray level value 1, how many number of times repeated? So 1, 2, 3, 3 times this also. And gray level value 2, so 1, 2, 3, 4, 5. 5 times repeated gray level value 2. So like that we have to calculate NK value for all the gray levels. That means how many number of times the gray level value is repeated in the given input image is nothing but frequency. So finally RK values are 0 to 7 because minimum is 0, maximum is 7, and NK is nothing but 3, 3, 5, etc. How many number of times each pixel value repeated? That means the frequency of each pixel value of the input image. So this is the first thing what we have to do while applying histogram equalization for the given input for better contrast of the input image. Now same thing whatever I have explained. So RK and number of pixels, 1 number of pixels, 2 number of pixels, and gray level value 3 number of pixels, 1 like that. So this is the first 2 columns clear. What is the gray level in the input image, what is number, and probability density function. What is the probability density function? So what is the formula that we studied in lower classes? P equal to M by N. M indicates favorable number of cases, N indicates total number of cases. So how many total number of pixels we have? 30. So 30. What's the probability of the gray level value? 0. So 3 times occurred. That's why favorable cases 3 by 30. So 3 is the number of times the gray level value 0 repeated in the given input image divided by number of pixels. So number of pixels, total number of pixels are 30. You can see second column sum, that is called number of pixels. Next, gray level value 1. So number of pixels 3. So what is the probability? 3 by 30. Next is gray level 2, number of pixels 2. What is the probability? 6 times repeated. That means frequency is 6. That's by 6 by 30. So like that, we have to calculate probability density function or probability for each gray level value. So that is nothing but third column. So this is clear. Now we have to find cumulative distribution function. What is the cumulative? In general, cumulative function is what is the meaning? Suppose if we take x value and f value, that is called frequency. This we studied 8th class or 9th class, and cumulative frequency. Suppose if we take x value 1, 2, 3, frequency value 10, 12, let us assume, so 15. So these are the frequency values. X values are available. And the corresponding frequency value is also available. So cumulative frequency means if we take the cumulative frequency at x equal to 1, same frequency value 10 copy paste, and cumulative frequency at x equal to 2, just add with previous value 12 plus 10, so that is nothing but 22. So that is the cumulative frequency at x equal to 2. Now cumulative frequency at x equal to 3, so previous value add 15 with 12, sorry 22, so 27, 37. So that is the cumulative frequency. So that means 37 is the cumulative frequency corresponding to the x value. So this is the way we have to calculate cumulative frequency of each x value. So just add with the previous value, which leads to the cumulative frequency. Same thing we are going to apply here also. So cumulative distribution function. So initially the probability PDF is 3 by 30, copy paste here. And first value always copy paste, whatever PDF, that is the same thing we can copy paste. And when you come to the next CDF, just add the previous value. So when x equal to 1, gray level 1, what is the cumulative frequency? 3 by 30 plus 3 by 30, which leads to 6 by 30. Next, 6 by 30 plus 6 by 30, 12 by 30. Next, 1 by 30 plus 12 by 30, 13 by 30. So 4 by 30 and 13 by 30, so 17 by 30. And 2 by 12, 17 by 30, so 19 by 30. Like that, we have to add, and 8 plus 19, 27 by 30. 8, 3 plus 27 by 30. So make sure that last value should be 1 always. Last value should be 30 by 30. So that's why whatever cumulative distribution we have calculated, that is 100% correct. There is no mistake while calculating the cumulative distribution function. Why means the final value should be 1. That means total probability should be 1. Next, we have to go for transformation, that is called L minus 1 into CDF. L indicates number of gray levels. How many gray levels you can see in the first column? Total gray levels 8. L minus 1 means 8 minus 1, 7. So 0 to 7 means number of gray levels is 8, and L minus 1 means 7, 8 minus 1, 7. 7 into PDF. So 7 into CDF, sorry, 7 into CDF, and we'll get the values and make a round figure, final one. So 0.7 round figure is 6, 1.4 round off is 1, 2.8 round off is 3, 3.0 round off is 3, and 6.3 round off is 6, like that. So we know what is the meaning of round off. So more than or equal to 5 means make it as next integer, otherwise make it as previous integer. So that's why whenever if we have 1.4, we are making 1. 2.8 means next integer, that is 3. So finally, we got the transformation. What does it mean here? So whenever if I take gray level 0, we can replace by 1. That's the meaning here. So the final transformation, wherever if we find 0, that we can replace with 1. So 1 is better than 0. That means contrast a little bit improved. And wherever 1, we can replace with 1 only. So according to the histogram equalization, wherever 1, replace with 1. Wherever 2, replace with 3. So that's why 2 replace with. Like that, we have to go for transformation. By using that, we have to replace the intensity values by corresponding transformation values by using histogram equalization. So that is the final column is the solution, and for first column, final column, wherever 0 replaced by 1, wherever 1 replaced by 1, like that. So this is the simple histogram, contrast enhancement technique, that is called histogram equalization. Sorry. So hope this table is clearly understood. So it's very simple only. Just we have to find probability. Just simple mathematics only, not that much complicated probability concepts also, like a data science, machine learning. It's very simple thing. Now finally, this is the input image, and this is the contrast enhanced image. So in wherever 0, we replace it by 1. You can observe that. So first element is 0, that we replace with 1, and third row, last column 0, that is replaced by 1, and fourth row, previous element is 0, that is replaced by 1. So like that, wherever 0, that we have replaced by 1. So this is finally image after histogram equalization. So this is the final conclusion, because I'm taking simple numeric example for better understanding. Suppose if you take 500 cross 500, 300 cross 300, then when you apply histogram equalization, we can find better contrast when compared to the input image. So hope the algorithm or histogram equalization technique understood. So now we will see Matlab Enhancement. It's very simple. Based on that, we'll see what type of output we can generate by using histogram equalization for contrast enhancement. So you can see this is the input image, original image and histogram. Original image, we are not able to see any objects, and histogram, all the intensity values are having low contrast. So that's why, and low contrast with high frequency, that's why we are getting the input image having low contrast. Now what we are looking for better contrast by using histogram equalization, so that all the intensity values are distributed from 0 to 255. Based on that, we can find better contrast. And after applying histogram equalization, the technique what we have discussed so far, so we are getting better quality, and we are able to see the objects also. Suppose if you are looking for objects enumeration or object in counting, then easily we can count. And as you can see, histogram also, the values are almost distributed across the histogram from 0 to 255. That's why we are able to see better contrast. But here in original histogram, high frequency, high intensity values not at all available. Very less high intensity values we have. So because of that reason only, we are not able to see proper contrast of the input image. So here also color image, and after applying histogram equalization, we are able to see better contrast. Now coming to the MATLAB, so it's clearly understood what is a histogram and how to make a histogram by using MATLAB, and what is the algorithm for histogram equalization. So what type of output we can generate by using histogram equalization. So these are the things we have discussed so far. Now how to implement by using MATLAB programming. What is the MATLAB function? So by using that, how to go for directly histogram equalization. So no need to write code, just we can use MATLAB function. So that is called hist eq, and the parameter is input image. So you can see here. So this is the simple MATLAB function. So imhist means it will display histogram of an image. Histogram equalization means hist eq, input is a low contrast image. So just we know what is the close CLC, clear all, close all, and we have to load the image, we have to read the image and convert it into RGB to gray. Of course, we will see later color images also, how we are looking for contrast enhancement also. That programs also will explain. And im show original image, that we know subplot image after histogram equalization. All those things I have displayed to display all the contents properly for comparison also. So here original image, obviously it suffers from poor contrast, and after histogram equalization we are able to see better contrast when compared to the original image. And here also histogram of the original image. So most of the intensity values having high frequency, that intensity values are low intensity values. So that's why we are not getting that much contrast in the original image. After applying image histogram equalization, then we are able to see pixel values are distributed or higher intensity values. Because of that reason, we are able to see proper contrast of the output image. So this is a simple MATLAB. Only thing is when I explained algorithm, so many things we discussed. But when you come to the MATLAB implementation, so we have a simple function hist eq, within bracket we can put the input image. Suppose if you go for Scilab function, imhist equal. So suppose I already told you, suppose if you don't have MATLAB software, you can go for Scilab, that is open source. Almost same functions, a little bit changes we have to apply. So suppose if you are looking for Scilab, the histogram equalization function is imhist equal. So but here in MATLAB, imhist eq, within bracket input image. Same thing here, we have original image, and after contrast enhancement, at the same time we can observe the histogram of original image and histogram of the equalized image. So up to this, whatever we have covered, that we will see hands-on. After that, I'll come back to the histogram equalization for color images or RGB images. But the logic is same, like what we have applied median filter for color images in yesterday's session. Same kind of procedure only we are going to apply for today's session also, for histogram equalization of a color images or RGB images or 24-bit images. So whatever we have covered so far, we will try to complete hands-on by using MATLAB. After that, I'll come back to the histogram equalization for color images. So just I'll minimize it and I'll move to the MATLAB. So I have already opened MATLAB. So now we have to discuss two things. So one is, so what is histogram, how to display, and next one is how to apply histogram equalization. So I'll go to MATLAB. So let me take new editor. Yeah. So always try to use CLC so that we can clear the window and close all the figures, previous figures. And next, let us assume I equal to, or maybe K equal to indeed. So we have low contrast images. Let me check what are the low contrast images I have in the data set. Low color 1. Low color 1 dot jpg, or maybe I can, okay, fine, any image, not issue. Now I want to, later we will see how to apply for it. I want to convert it to grayscale. So for single channel processing, RGB to gray, K, and how to apply histogram equalization, N equal to, so hist EQ within bracket, so input image, that is called B. Now I can go for subplot. So 2 rows to 1 row, 2 columns, 1, 2, 1, image position is 1. In show, what is the original image here? So B, grayscale image I'm taking. Title, original image. Next, subplot, 1, 2, 2. One row, two columns. The image location is 2. Second. So in show N, that is the equalized image. So title, original image, and contrast N and image. So let me run this program. So make it as some test 15, some name I'm giving. I think some error. So what is that error? So because if no output means you'll get some beep sound which indicates some error is there in the program. So line 9 subplot show title image. What is that? Attempt to execute script. Line 9 subplot 1 to 1 show the original image. So there's no issue. Just a second, I'm checking what is the problem in the program. Subplot as a function. Subplot.m. Maybe yes, somewhere I have stored as a subplot. Similar kind of what Nirmala madam got the errors. Yeah, here some subplot is there. I'll try to change that name instead of something. I'll try to make it as some other name. Rename. So make it as a subplot 1 1 something. Fine. Hope now we'll get output. Yeah, now you are able to see. So original image and contrast enhanced image. So in original image, we are not able to see the objects properly. So when you come to the contrast enhanced image, so we are able to see objects properly. So this is a grayscale image I'm assuming considered. Suppose I want to display histogram also. For that, what we'll do? Histogram in history. Subplot. I'll make 2 rows, 2 columns, and histogram is 2 rows, 2 columns. The first position is original image and subplot 2 to 2. The histogram in the B is the grayscale image. Title histogram of original image. Next, so 2 to 3. 2 to 3. Contrast enhanced image. Subplot 2 to 4. 2 to 4. You can separate by comma or you can type as it is, no problem. 2 to 4. In hist N. N is the enhanced image that histogram we have to see. Histogram for HE image. Histogram equalized image. That is the meaning. HE means histogram equalized. Now let me hope you are able to see. So when you come to the original image, the contrast is not equally distributed and low intensity values having high frequency. Because of that reason, we are not able to see properly. The contrast we are not able to see properly. Whereas if we come to the contrast enhanced image, the intensity values are almost all are equally. That's why equally histogram equalization. We are equally distributed. That's why we are able to see proper contrast of the output image. Just a second, I'm getting call. Hello. Oh, sir, can I call Simon session? Sorry. So we are able to see original image and contrast enhanced image. Similar way, histogram of original image and histogram of contrast enhanced image, and by using the function imhist. So for histogram equalization, HIST EQ, for display histogram, just we can use imhist. Maybe some other images also we can see. Low, JPG. Let me check for other sample images. So here also, yeah, I'm executing for other samples also, other test samples also, test images. So original image, and as you can see the contrast enhanced image along with histograms also. Maybe low one, let me check, is there any image low one? Yes. So here also, so we can see original image and contrast enhanced image. In contrast enhanced image, so better when compared to original image. So I did not specify so far. Histogram equalization is the best like that. Every method having pros and cons, but this is a basic image enhancement technique. By using that, we can increase the contrast. Next, if we take low 2, so here also, so original image and contrast enhanced image. The program is very simple, but only thing is concept we should know. That's why I explained the algorithm. What is the algorithm for histogram equalization? By using that, how to display the histogram of original image and enhanced image. Same for output images. So maybe low 3. So here input image we are not able to see clear image. So when you come to the output image, we are able to see properly because of good contrast. Okay, so now I'll move to the presentation. So how we are going to apply for histogram equalization of RGB images. So for histogram equalization of color images, whatever images we have considered so far, all are grayscale images. But here the concept is very, very simple. That what we have discussed even in previous session for median filter, we know how to apply median filter for grayscale image as well as color images. Here also the concept is same, but function is different. Suppose if we take histogram equalization for color images, that is called let me use some different color. So RGB images. So we have, let us assume RGB. So this is called 24-bit image or color image. So first we have to decompose into 3 colors. One is R. We know how to extract R color, how to extract green color, how to extract blue color. This we already discussed in previous session. Suppose if we have a color, so color image, how to display 3 colors, that is called RGB images. So first we have to extract 3 colors RGB separately. After that we have to apply histogram equalization, hist EQ for red color. Next we have to apply hist EQ for green channel, that means green color. After that we have to apply hist EQ for blue channel. So these are the 3 histogram equalized images. Once it is done, we have to concatenate, we have to merge all the 3 histogram equalized images. So for that we have discussed one function that is called cat. So CAT. So once if we merge these 3 images, so then we will get output image. So that is called contrast enhanced image, CEI, contrast enhanced image. So this is the final output what we are expecting. So this is a procedure for applying histogram equalization, or HE, we can call it as histogram equalization is HE to the given grayscale, RGB images. We have to extract colors. After that we have to apply histogram equalization for each color. After that we have to concatenate, or we have to merge by using cat function. Finally we'll get histogram equalized image for given RGB image or color image. So this is the procedure what we have applied for median filter. Same thing we are applying for even for histogram equalization for color images. So this is the diagram what I have explained previously also. So we have input, whatever I have explained, same thing, input image. So first we have to extract red channel, green channel, blue channel, then apply histogram equalization for each channel, then we will get output image. That means after merging these 3 output images of histogram equalized one, we will get final output image, that is called contrast enhancement of the given input color image here, not grayscale image, color image. So we have to merge finally by using the cat function. So this is a simple flow diagram for applying histogram equalization for given input image or color image. So you can see this is the input image, and after contrast enhancement of the color image, we are able to find better contrast, and we are able to see all the objects, whatever objects available in the photo, that we are able to see. But before in histogram equalization, we are not able to find one object, but here we are able to find better in the histogram equalization. Now coming to the Matlab code. So for histogram equalization for color images. So the logic is very simple. So we apply histogram equalization for grayscale image, but here we are looking for three channels, that is called RGB. So we have to apply histogram equalization for three channels. After that we have to merge, we'll get out. The simple logic, whatever we have discussed for grayscale images, just we have to extend little bit. Based on that, we can find contrast enhancement of the color images. So here you can see the Matlab code, CLC to clear the window, and close all to clear to close all the figures, and we have to read the image, or we have to load the image by using inread function. So let us assume low color is the color image I am assuming, JPG file, and we have to extract the each channel. After that, we have to apply histogram equalization. So whenever we have color image, so red channel, that means red channel how to extract. So I is the input image, so is 2 comma 1, it will extract the red color. If you put 2, it will extract the green color. If you put 3, it will extract the blue color. Sorry. So, but we have to apply histogram equalization for each color. So that's why hist eq. So first channel, that is called red channel. So the m is the variable where the input color image is stored. So from that I have extracted red channel. Next blue channel I have to extract. After that we have to extract blue channel and apply histogram equalization. So we have applied histogram equalization for all the three channels, 1, 2, 3 channels. 1 indicates red, so 2 indicates Z, 3 indicates blue. So that means we have applied histogram equalization for all the three channels of the input color image. Now what we have to do, we have to concatenate, we have to merge. For that we have to use cat function. So cat, we have 4 parameters. First parameter is dimension. So because this is a 3 dimension, because each pixel is a combination of the intensity values, that is called RGB, and rest of the 3 parameters are R indicates red channel, Z indicates green channel, B indicates blue channel. So we have to match all the 3 channels, and the output image stored in the variable V. So finally we have to display im show me. So we have to, this is the contrast enhanced image, this is the original image with the low contrast. So this is very simple. Only thing is we have to apply histogram equalization for all the 3 channels, followed by we have to merge, or we have to concatenate. Based on that we can find the output image of the input image. So for loop, we required for loop. Suppose instead of applying 3 times histogram equalization, why can't you use for loop? So for that we have to go for loop. Even I explained previous class also. It's very simple for loop. So for variable I equal to initial value is to final value 10, whatever instructions you can write, and end. So that is end of for loop. So while making the condition 1 is to 10 means 1 is the initial value, 10 is the final value. That means each time the value of I is incremented by 1. That is the meaning here. So 1 to 100 means, so 1, 2, 3, 4 like that. If you are not specified explicitly how much we can call it as a step value, or how much value we have to increase, then by default we take it as a 1. So that's why if you want to specify the step value 2, 3 like that, so initial value is to step size is to final value, whatever instructions we have to write, that we can write here, and end of the one. So this we discussed also. So without writing 3 times the histogram equalization, why can't you go for 1, so that we can minimize the time? For that we can go for loop. So I'll show some examples for better understanding. So if we take for I is to 3, that means I value 1, 2, 3 and display I end. So end of the for loop. Always for loop is closed by end keyword. So that's why we have to mention end. So for I equal to 1 is to 3, that means I value will take 1, 2, 3 and display I value and end of the festival, whatever it may be. So here you can see 1, 2, 3. So finally we got output values 1, 2, 3, because each time incremented by 1. If you take one more example, here I specified the step size. So each time I have to increase the value of I by 2. So DASP display function, to display any variable, we can go for this function, or we can use fprintf also, your convenience. So display is the function, by using that we can display the value of the variable. So I1 is the initial value, next each time 2 is increased, so that's why we are getting 135, because the step size is nothing but 2 here. Next here decrement. So 5 minus 1 1. Each time it will decrease it by 1. So 5, 4, 3, 2, 1. So that is the meaning here. So minimum is 1, maximum is 5. That is 5 to 1. It will display, and with the decrement 1 value. So here also minus 1 decrement. So 5, 4, 3, 2, like that. So this is a simple for loop. Why I am explaining this one is, so instead of specifying hist equal 3 times, we can use for loop. So based on that, we can get output easily. Because if we have, let us assume 100 times, if you want to display something, we can't wait 100 times the statement, display statement. Because of that reason, we can go for loop. Now, how to apply Matlab code for histogram equalization for color images using for loop? So just I am using, so same logic what we have applied, CLC close the window, and we have to read the image, that is we have to load or read the image low color, and we have to apply for loop, because instead of writing 3 times, we can go for one step, that is by using for loop for I equal to 1:3, or we can write 1:1:3, your wish 1:1:3. What does it mean? So each time I value is increased by 1, that is the meaning here. And I have to apply histogram equalization for the input image, color image here. So I value will take 1, 2, 3. When I value will take 1, here 1, 1. So that means, so the red channel enhance, and the resultant value is stored in the, so z variable is channel 1. If I equal to 2, next channel green channel is enhanced, and the resultant value is stored in the variable z with I value is 2. Similarly 3, so I value becomes 3. Based on that, we apply histogram equalization for all the 3 channels. Now, how to combine, that is important. So end of the for loop. So always for loop is terminated by end. So how to display this one? Directly in show. So here concatenation is not required. So directly we are using one variable z, and whenever I value varies from 1 to 3, all the values are stored. So finally you'll get enhanced image, that is it. Suppose if you want to use cat function, that is called concatenation, you can use cat m1, m2, m3, like that also. Nothing is wrong, you will get output, but unnecessarily wasting time to use. Suppose if you don't know this algorithm, whatever we have discussed, just you can go through that standard library function. By using that, we can display the histogram equalizer color images. So you can see here original image, original color images. I'm talking here original color images. Here we are not able to see properly the object. After enhanced color image, we are able to see objects properly. That means color enhancement will give better insights of the organization, or better insights of the data. Or maybe we are talking about images, so image. So here we are able to see better quality, and we are able to see objects also. Maybe here also original image having low contrast, after enhancement we can find better contrast. Same thing, suppose if you take this example, if you want to count how many number of students just for attendance calculation, if you take low contrast image, we are not able to see properly number of students, but when you come to the enhanced image, we are able to see properly number of students. Based on that, we can go for more accurate count of the students, or we can call it as a, so how many number of students we can see properly. So this is the way we can apply histogram equalization for color images. So the spatial convolution, I will come back later. I will execute whatever we have done for color images. So just a second, I have to sign for answer sheets of the examination. Just a second, just hold it. So if you have any queries, you can type in the chat box. Meanwhile, I will read it after the signatures I have. Just 1 minute maximum. Because we have to send answer sheets to the university. Mohan. Manju.
Hello, sir.
Man, just a second, madam.
Yeah, okay.
So now we will see how to do implementation by using Matlab. I'll come back to the Matlab. So just I'll make a new editor because we have exams are going on, that's why. So just we'll apply the filter for color images. So same similar code, just what we have discussed, that I'll execute now. So close all. P equal to indeed. Let us also low. The image is color APJ. So we have load the image. Now we have to extract each channel. Let us assume R equal to P, and we have to extract a red channel. So that's why is 2 comma 1. We know how to extract or G equal to P is 2 comma 2. Next RGP P equal to P. The input image is P. The color image stored in the variable P is 2 comma 3. Now we have to apply histogram equalization, or directly also you can apply R equal to HIST, or just for better clarity. So leave it. So now we have 3 channels RGB. There we have to extract 3 dip. Now we have to apply, let us assume R1. So we have to apply Hist EQ to the red channel, or next Z1, make it as a label. So Hist EQ, so the channel is G. Next RG B1, B1 equal to Hist equal, so B RGB. Now histogram equalization done for all the 3 channels. Now we have to concatenate. We have to merge all these. Let us assume B equal to CAT function, and dimension is 3. The equalized images are stored in the variables R1, G1, P1. That's why R1, comma G1, comma. This I have explained in the presentation also. Now finally, so we can go for subplot. So 1 row, 2 columns, 1 comma 2 comma 1. So in show, the original image is P, comma title of the image is, so original color image. Next subplot 1 comma 2 comma 2 in show, and the resultant image stored in the variable B. So comma title enhanced, we can call it as a contrast enhanced equalized image. So let me run this program. Some name we can give test. So always make sure that the function name and program name should not be same. So that's why I'm giving test something like that. Text test 16. So some sound I received, that means some error is there. What is the error? Close all. Find, yeah. So you can see instead of close all, I use a CLSOE. So that means spelling mistake. So that we have to rectify CLOCE. CLOSC, sorry. close all. Now we'll see what. Yeah. Now we are able to see the input output image properly. We can see input image and contrast enhanced equalized image, color image. Original image is color and enhanced image also color image. Maybe we have other images. You can see in the images folder. So what are the, yeah, low, we have the name, it starts from low. So let us assume low 1, like that I have. So low 1 color image, low contrast and better, and low 2, and we are able to see better contrast. You see output image. So original color image having low contrast, in the enhanced color image having better contrast. Now we can see low 3. Low 3, this is the grayscale image. Low 4, similarly grayscale images. So maybe any other color images. Just I'm checking the database. Any other low color images, low contrast images. Yeah, fine. So whatever images we have, we executed. Now in this one, what we have done, we have applied histogram equalization for 3 channels. After that, we have to match all the 3 channels. Then we have displayed. So unnecessarily repetition of the code and unnecessarily wasting of time, all those things. That's why we have to go for loop. So no need to write like this yeah, step by step with lengthy code. I want to minimize. For that, we can go for loop. So same code, I'll copy paste. Otherwise, I'll go for some new. So let us assume CLC close all. So let us so low 1 dot jpg. I can go for directly for I equal to 1:3, and let us assume so V is 2 comma I. That means I value 1 means so first channel red channel will be enhanced. So I value 2 means next channel green. I value 3 means next blue channel, like that. All those variables enhancement is stored in the variable V. So that is the enhanced color image. So equal to HIST EQ. Now M is 2 comma I. So end of the for loop. So you can see just one line code only. So just V is a variable. There we have to store the color enhanced image, and I value varies from 1 to equalization for all the 3 channels of the original image, that is called M. Now just we have to display the image. So subplot 1 to 1 show original image is M. So title leave it. Subplot 1 to 2 show V. Title enhancement. Hello. Hello. Oh, madam. Hello, madam. 8th semester, 6th semester with అనుకున్నాను మేడం. హెచ్ఆర్ వచ్చారు మేడం. నేను నాకు కొంచెం సెక్షన్ ఉంది, 10 minutes తర్వాత వచ్చి మాట్లాడాలి. లేకపోతే నేను హెచ్ఆర్తో మాట్లాడతాను. 6 ఇద్దామని నేను డిసైడ్ అయ్యాను. ఎందుకంటే ఆ ల్యాబ్ సార్ తప్ప ఎవరు తీసుకురాలి. ఏంటండి 8th సెమ్ మేడం. ఇంతకుముందు 7th సెమిస్టర్, 5th సెమిస్టర్. మేడం చెప్పండి, నేను హెచ్ఆర్తో నేను మాట్లాడతాను. బ్రేక్ లేదన్నా ఓకే నేను మాట్లాడు సో టైటిల్ ఒరిజినల్ ఇమేజ్ now let me run this one text 80 some error I'm getting. So unbalanced or unexpected parentheses in the line 7. Yeah, so we forgot to close one more bracket. Now we get some error. So line 7, subscripted assignment dimension mismatch. Hist equal m, maybe low 2, let me use that color images we have. Color 4 letters. Low color 3. Low color 3. Just a second and subscripted assignment dimension mismatch. So here color one. Let me check. For I equal to 1 to 3 times, so each time we have increased the value by I equal to 1, but still we are getting error. Subscripted assignment dimension mismatch. The problem here. I think some error we are getting. Line 7. So here we are getting, when you apply individually histogram equalization, we are getting there is no issue. But while are using for loop only, we are not getting error. Let me check maybe any other issues. I have tried similar program previously. Yeah. So here we can see in this program we are getting here. Sorry for this disturbance. So I'll make it as a this around. I will try to remove this. Yeah. So here you can see in this program there is no issue. So CLC here all the commands the closer init just for I equal to 1, just I increase each I value by 1, otherwise you can take 1:3. So and hist equal, and for input image I'm taking channels 1, 2, 3. That's why I have to go for I equal to 3. Just I applied histogram equalization for all the 3 channels. Just I used for loop. So we are getting output. We are able to see here. So, but not that much better contrast. Still some blurring is there, but we are able to see better contrast when compared to the input image. So here the my objective or my intention is how to apply for loop. Just we have to use for loop whatever program we executed previously, instead of applying 3 times and displaying the output after combining or merging the three channels. So here just I have used the for loop for I equal to 1:3. Then I have stored the resultant value. Just a second. Madam. Madam, just 5 minutes, madam. Meeting room. So we applied histogram equalization. So after that, we are getting output image, that is Z. So when you run this program also, we are able to see this. So this is the way we can apply histogram equalization for individual channels like RGB, or we can go for loop, and one stretch we can try to apply. Based on that, we are able to see output image, that is called output enhanced color image. Just I'll come back to the presentation. So just a second. This we have completed already. Now I'll move to the next one, that is called linear spatial filtering. For that, we should know what is a spatial convolution. After that, we'll see what type of filters we are going to apply for noise reduction. Of course, we have other histogram processing techniques also for contrast enhancement. So I think it's clearly understood what is histogram, what is histogram equalization, what is the algorithm, and how to apply histogram equalization for grayscale image, and how to apply histogram equalization for color image, and how to apply for loop for color image for histogram equalization. That we have discussed theoretically as well as hands-on also we executed. And next one is how to go for spatial filtering, that is spatial linear filters. So also when you go for edge detection also we require this basic idea, that is called convolution process. So spatial convolution. So we have here kernel and input image. So input image we have to apply kernel or mask to the input image. So W1 Z1 we have to apply to the input image. Just we have to make multiply and make some W1 Z1, W2 Z2, W3 Z3. So just we have to multiply and make some. Similarly, W4 Z4, W5 Z5. This is not matrix multiplication. This is called convolution process. So let us assume W6 Z6 and W7 Z7. Like that, we have to do convolution operation. So that is called. Let us assume mask is. Let us assume W, and the input image is. Let us assume Z. The convolution process is denoted by W star Z. So this is we can call it as a convolution process, W star Z. So the resultant value is nothing but response or equal to. So just whatever I have done the process, W1 Z1 plus W2 Z2 plus W3 Z3. So that is called convolution. After applying convolution, the resultant value is nothing but response. This response value we have to replace the central pixel value of the input image while applying linear filters, that we will see later. So here time being, what is convolution process means? Just multiply and make some, so that we'll get a convolution process, and the resultant value is nothing but response. So that is denoted by summation Wi Zi. What is the meaning of this W1, W2, W3? This we can call it as a weights. So depends on the application, we can consider these weights, so that we will see what type of weights we have to consider for smoothing, what type of weights we have to consider for sharpening. So like that, we have other concepts that we will see later. But time being, so W1, W2, etc., we can call it as a weights. So when it come to the spatial filtering process, so this is the kernel. We know what is the meaning of kernel. It is a small matrix, and we can take it as a 3x3 or 5x5 or 7x7. We can call it as a mask or kernel. So this we have to apply to the original image. So just we can apply to the original image. That process also we discussed, left to right and top to bottom, like that. While I explain median filter, I have explained clearly. So the central pixel value we have to replace by response. Whatever response we got after convolution process, what we have applied just now, so that central pixel value we have to replace with response. So finally here you can see new pixel value is nothing but response here. So this response can be either average value, or we can call it as a mean value for linear filters. When you go for median filter, we can call it as a median. When you go for max filter, we can call it as a max. But whatever max median filter we applied, the kernel is nothing but always once only. All the values are always one. Just we can do a convolution also, it won't make much difference. But when you come to the linear filtering, or maybe sharpening edges, etc., the kernel is different. Some kernels are having some different values, some kernels having some non-zero values with some is always zero. Like that, we have various cases possible. So such type of scenarios, the response is different in which we have to replace central pixel value by response. So through example also I will explain, don't worry about this one. But the basic idea is, what is the convolution? Just we can multiply, make some, that is called convolution, and the resultant is nothing but response. This response we have to replace with the central pixel value of the input image. And this kernel we have to apply to entire image, not only first 3 by 3 submatrix. We have to entire image we have to apply until we reach the last pixel value of the intensity value. So let us assume this is the kernel and this is the input image. What we have to do here, if we take this 3 by 3 submatrix, let us assume this 3 by 3 submatrix. I'm assuming first we have to apply kernel. So what is the response value? So 2 into 1 plus 2 into 1, like this. This 1 into 2 plus this 1 into 2, this 1 into 2. Similarly, minus 1 into 2 and 2 into 1 and 1 into 3. Next, minus 1 into 2, minus 1 into 2, 1 into 1. Like that, we have to multiply and make sum. The resultant value, whatever response value we will get, let us assume the response value is 7. That central pixel value we have to replace with 7. So this is the convolution. Once if we done first 3 by 3 matrix, then we can move next 3 by 3 matrix. So the similar process we discussed in median filter. Only thing is, there we used to calculate median of this 3 by 3, but here we have to do convolution process, and this central pixel value we have to replace by response value. Next, once if we done left to right, now no more top to bottom. This 3 by 3 we have to consider. Next 3 by 3 we have to consider. Like that, we have to apply this convolution process, and the central pixel values we have to replace by mean value, response value. If you are taking mean, you can replace by mean. If you are taking some other value, you can go for that response value. So this is called convolution process, followed by replace central pixel value by response value. So this is the output image we will get after applying convolution, what I have explained just now. So now we will see what is a linear filter, that is called mean filter or average filter, and what type of kernels we are going to use. Maybe we have again two types. One is mean filter and one is weighted mean filter, or average filter, and one more is weighted average filter. So these things we'll discuss in detail with mathematical intuition and also Matlab code execution, all those things. Here the basic idea of mean filter is, so find the mean value of this 3 by 3 matrix and replace central pixel value by 5. By assuming the mask values are all equal to 1. Suppose if mask values are different, then we can go for some other mean value that we will see how we are going to calculate. So these things I'll explain next section. So I'm getting called from principal. So these filters, and we have one more important concept, segmentation. And what is segmentation, what is edge detection, and how to apply MATLAB code. All those concepts left that we'll try to complete tomorrow's session. Even research directions also I will explain tomorrow's session. So whatever papers I have published, that only I will show. And just a minute, man. I'm coming in 1 minute. So, sorry. Additional resource to learn for digital image processing. This I have displayed yesterday's section also. So same textbooks only. Maybe if you find any other textbooks also fine. These are the standard textbooks. So that was my talk. So whatever topics pending and segmentation, edge detection, all those things, tomorrow class we try to wind up with the MATLAB code executions. Yeah, thank you. If you have any queries, you can send mail. I will give reply, or maybe if any other queries, maybe complicated queries, means I'll try to explain in the session itself. Maybe still 2-3 mails still left, not replied. I will try to reply in free time. So hope you can understand my situation here. So thank you all. So we'll meet tomorrow's session.
Thank you so much, sir, for your valuable presentation. As we come to the end of our event, I would like to take a moment to express my gratitude to all of our joining us today. I would like to start by thanking our distinguished speaker, Dr. J. Somashekar, for taking the time to share their expertise and insights with us. Your presentations was engaging and informative and thought provoking, and we all learned a great deal from your experience and knowledge. Before we wind up the session, let me give a small announcement of our upcoming program. IFERP Project Competition 2023 Idea Phase in partnership with SRM College and Chandigarh Group of College. How IFERP projects How IFERP Project Competitions 2023 will operate. First, project competition idea phase, then evaluation, screening, and shortlisting by scrutiny committee, and then announcement of round 1 result, submission of POC, and evaluation by scrutiny committee, and announcement of round 2 results, and then final offline project demonstrations, winner selection by the committee, and the dates which we have given here is like 25th February 2023 and 3rd March 2023, 31st March 2023 and 7th April 2023. And the final offline project demonstration is going to be 21st and 22nd April 2023. Okay, now I would also like to thank all the participants who attend our today's event. Your active participations and engagement throughout the session made the event more enjoyable and valuable. Your questions and comments and insights have added depth and breadth to the discussions and have helped us all to learn and grow. And for your information, our final session will start shortly at 3 p.m. tomorrow. Thank you all.